Every advanced chip on Earth depends on one company. Apple needs it. Nvidia needs it. Samsung needs it. Without this company, modern AI stops. It's called ASML. And somehow, one small Dutch company became the single bottleneck of the entire semiconductor industry. The problem nobody wanted. Chips get faster by getting smaller. By the late 1990s, the industry hit a hard limit. The light used to draw circuits onto silicon wasn't precise enough. The wavelength was too long. Physics, not engineering, was the ceiling. The solution was extreme ultraviolet light, EUV, short enough to draw at atomic scale. The catch: EUV is destroyed by contact with almost everything. Air kills it, glass absorbs it. One oxygen molecule in the beam path, and the process collapses. Nikon ran the numbers and went back to making cameras. Canon ran the numbers and went back to making cameras. Both made the rational call. ASML decided to solve it anyway. That decision nearly destroyed them. It is also why, 3 decades later, they hold the most defensible position in global technology: the machine. Inside a chamber the size of a double-decker bus, running in a vacuum cleaner than outer space, a laser fires at a droplet of molten tin. Twice. First shot flattens it into a pancake. Second shot vaporizes it into plasma at 500,000 degrees Celsius, 40 times hotter than the surface of the sun. That explosion produces EUV light. It happens 50,000 times per second, without pause, without error. The light bounces off Zeiss mirrors, the smoothest surfaces humans have ever built. Scale 1 to the size of Germany, and the tallest imperfection would be under 1 millimeter. Fractionally less smooth, and the light scatters like a drunk laser pointer. Your $500 phone ends up with the processing power of a 1995 Nokia. One machine, 100,000 components. 3 Boeing 747s to ship. 1 year to install. $200 million for the standard model. 380 million euros for the high NA version, the one the next generation of AI chips requires. There is ASML, and there is everyone else still trying to catch up. Pay us to keep failing. By the early 2000s, ASML had been working on EUV for years, with nothing functional to show. Cash burning. Technology failing in new and creative ways. Then CEO Peter Wennink walked into the boardrooms of Intel, Samsung, and TSMC, his future customers, and technically his future hostages, with a pitch that had no business working. If we fold, the entire semiconductor roadmap hits a wall. Your chips stop getting faster, so pay us to keep failing, or explain to your shareholders why progress stopped. A room full of venture capitalists would have called security. Intel, Samsung, and TSMC wrote the checks, investing billions and taking 23% of ASML's stock. They funded the company that would make them permanently dependent on it. Either the worst negotiation in tech history, or proof that Wennink understood their situation better than they did. That investment bought ASML a 30-year structural lead that money alone cannot replicate. China has been trying seriously since 2018. Current estimate, 10 to 15 years behind, minimum. The real business model. The machine sale is not the business, it is the setup. ASML engineers live on site at TSMC, Samsung, and Intel fabs, not temporarily, permanently. These machines require constant recalibration using proprietary parts and software that come exclusively from Veldhoven. No third-party technician exists. No alternative supplier exists. Without ASML's people present, machines drift out of spec. Gradually, yield drops, defects rise, not because of a remote kill switch, but because the complexity that makes them work requires continuous maintenance from the people who built them. When the US wanted to slow China's chip ambitions, they pressured the Dutch government to pull ASML's service licenses. ASML stopped sending engineers and updates. Chinese fabs still have machines, running on borrowed time, slowly falling behind spec, with no recovery path. ASML didn't threaten anyone, they just didn't show up. Where the real money is: 2025 revenue, 32.7 billion euros. 2026 guidance, 40 billion euros. But the number that actually explains ASML's position is inside a division called Installed Base Management, servicing machines already sold. It generates nearly 30% of total revenue, at margins higher than selling new machines. ASML makes more money per euro maintaining old equipment than selling new hardware at 380 million euros a unit. The structure: sell the machine once, charge for every calibration, update, and proprietary part for the next 20 years. The customer cannot go elsewhere. If they stop paying, precision degrades, and the 380 million euros machine becomes an expensive problem. TSMC and Intel flag ASML pricing as a concern in every earnings call. Then they pay every quarter without exception. As CEO Christophe Fouquet put it in May 2026, "No one is coming for us." The one real threat, the most credible threat to ASML, is their own invoice. At 380 million euros per high-NA machine, the ROI calculation is getting uncomfortable. If enough customers decide the yield improvement doesn't justify the cost, the upgrade cycle stalls. Moore's law doesn't need a physics barrier to end. A spreadsheet is sufficient. Canon is betting on this. Their nano-imprint systems stamp chip patterns mechanically. No plasma, no mirrors, no molten tin. 10 times cheaper, 90% less energy. Not ready for leading-edge AI logic yet, but already taking memory market share. And chipmakers are quietly revisiting multi-patterning, an older technique that stretches cheaper existing machines further, trading efficiency for a lower entry cost. Intel looked permanent. Nokia looked permanent. Kodak looked permanent. Monopolies rarely collapse to better technology. They collapse when customers get tired of the toll. The number on ASML's own quote is the only competition they have. The point. Real leverage sits at the single point nobody else can replace. Apple designs. Nvidia calculates. TSMC manufactures. ASML makes all of it possible at the frontier, not by competing everywhere, but by spending 20 years becoming the only credible answer to one brutally hard problem. Every serious AI model running today, every flagship chip, every data center built this decade, all of it passes through one unremarkable Dutch town where the coffee is average and nobody is waiting for a Forbes profile. That's not an accident. That's the strategy. This is broke genius.